In this video, we are going to take a look at what is work measurement. So, we have studied what do you mean by method study. So, in method study, what we are doing is that we are creating a method, a standard method to do a job. And in work measurement, what we are going to do is to measure the time taken for doing the job using the standard method. So this is what is called work measurement. Okay. So so it is the application of techniques designed to establish the standard time for an activity. So we know what is a standard method. Now we are fixing the standard time to do that job using standard method. Okay, standard time for an activity, a qualified worker at a defined level of performance. Okay, so this standard method should be done by a qualified worker at a standard level of performance. Okay, so this is called work measurement. And standard time, so this is all about finding the standard time. So it is defined as the time taken by an average experienced worker for the job with provisions for delays beyond the worker's control. Okay, so these are called allowances, which we will discuss in detail in this video. Okay, so work measurement starts with investigating and eliminating ineffective time, providing basis for method study. Okay, so this see, we have already found the standard method, then we are going to measure it. But while measuring the standard time, we can eliminate ineffective time. Thus, we can modify the method also. So indirectly, it can help in fixing the method. Usually, standard method is found out, then you are doing the work measurement. Okay, so let us look at the objectives of work measurement. So that means it is to reveal the existence of ineffective time, if any, and then we are setting the standard time for carrying out a specific job and standard output level. Okay, so what are the different techniques of work measurement? So there are several techniques. The important ones are time study, work sampling, standard data method, and predetermined motion time system. So out of this, we will discuss about time study. So that is the most important technique of work measurement, which will be discussed in detail in this video. So let us go to time study. So time study is the most versatile and the most widely used technique, and it is used to estimate the time to be allowed to a qualified and well-trained worker working at normal pace to complete a specified task by using specified method. So this is the important thing. You need to fix the standard method that is determined by the method study. Then this job is done by a qualified worker or a average well-trained worker at a normal pace. So this is called the standard time. So in time study technique, using these techniques, we will fix the standard time, and based upon which we can determine the wage system, okay, and other perks and incentives. Okay, so this technique is based on measuring the work content by the prescribed method. So this prescribed method with the allowance for fatigue and for personal and unavoidable delays. Okay, so when we set the standard time, we will need to include the allowances. So these allowances means for fatigue and for personal. The worker may have some personal problems and he may have fatigue while doing the job. So you need to put allowance time for that. So standard time includes all the allowance also. Okay, now let us see what is the procedure for the time study. So the first step is to define the objective of the study. That means say this is all about the statement of the use of the results. What is the use of the result? So how much precision you require for the standard time? What is the precision level and the required level of confidence in the estimated time scale? Actually, we are estimating a standard time. How much precision you want for this? Okay, and at what level of confidence you should have in this estimated time standard? This should be defined properly. Then you should verify that the standard method and conditions exist for the operation and operator is properly trained. So you need to determine the standard method, and also you need to fix the operator who is going to do that job using the standard method. If a need is felt for method study or further training of operator, the same may be completed before starting the time study. Okay, so if you want to train the operator, it should be completed before starting the time study. Next, you need to select the operator. Okay, you need to select the operator to be studied if there are more than one operator doing the same task. And in step 4, you need to record information about the standard method, operation, operator, product, equipment, and conditions on the time study observation sheet. You have got an observation sheet and you need to write down, record the information about this, what is the standard method, operator, operator name, etc. In step 5, divide the operation into reasonably small elements, which we will see how we can divide the job into different elements. Okay, and record them on the time study observation sheet. A given job can be divided into various elements, okay, like 1, 2, 3, 4, and we are going to record the time for taken for each of these element. We will see how we can divide the job into various elements. Now, okay, then we will time the operator for each of these elements. Okay, for each element we will time. Then that is to record the data for a few number of cycles on the time study observation sheet. Okay, that means, see, one job, see, this job is done for many cycles. So again, 1, 2, or 3, we will repeat that this recording process for various cycles. Okay, it is not limited to one cycle. We will do maybe 5, 6, up to 10. So more the number of cycles, more will be the accuracy. Okay, for each cycle you will record the time taken for these various elements, right? Then finally we will take the average. Okay, we will take the average time for each element for different cycles. Then we will collect and record the data for required number of cycles by timing and rating the operator. Okay, we will time and see. This is also an important part. So we need to record the data. See, we will time each element. We will calculate the time taken for each element, and by applying rate, so we need to apply rating on the operator, so which will also be discussed in detail. Rating means if the time study man feels the worker is working at a normal pace, then rating can be 100%. So if he feels that he is working at a high speed, then higher rating like 120%, 150%. And if it is working at a slow speed, then you can see that 90% can be applied. So how this rating factor, fixing this rating factor is very important, and that will also be discussed. In step 8, calculate the representative watch time for each element of operation. So I have told you there are various elements, 1, 2, 3, 4, etc. Then we will, for this is carried out for different cycles, 1, 2, 3, 4, etc. Then we will calculate the average. Okay, so we will calculate the watch time for each element of operation. Then we will multiply by the rating factor, just like I have seen, like 100%, 120, 90% like that to get the normal time. Then, so the normal time will be the observed time into rating factor. For example, you are getting observed time as 5 seconds. Then if the worker is working, time study man feels that his worker is working at a high speed, if the rating is 120 percentage, so it will be 120 by 100. Okay, it will be 6 seconds. So calculate the normal time for the whole operation by adding the normal time of its various elements. So each element you have calculated the time, right? Time for like T1, T2, etc. Then we will sum all this time to find the normal time for the whole operation. Okay. In step 9, we will determine the allowances for fatigue. So this is for calculating the standard time, we need to include allowances for fatigue. For example, if it is total time for an element is for a job is maybe 2 minutes, then 20% allowance may be given. It depends upon. We need to determine the allowance. Okay, so for after giving 20% of allowance, then that will be total 2.4 minutes. Okay, then determine the standard time of operation. So after adding the allowance, we will get the standard time. So that means standard time will be normal time plus allowance. Okay, so normal time plus allowances. So these are the steps in the time study process. Okay, so in the time study process, we have discussed about timing the various elements of a job. A job is divided into various elements like 1, 2, 3, 4, etc. So how can we divide this? What are the different types of elements? How can it be divided into elements? That will be discussed here. So timing a complete task as one element is generally not satisfactory. You cannot take this job as a single element. So what we are doing is, for the purpose of time study, the task is normally broken into short elements and each element is timed separately. Okay, so this is to increase accuracy in rating, improve accuracy. So this is one reason is to improve the accuracy. The worker may not work at the same speed throughout the cycle. He may perform some elements faster and some slower. Okay, so timing the element helps to improve the accuracy of the calculation of the standard time. So breaking of task into short elements permitting of each element separately offers more realistic than just rating once for the complete cycle, because the operator may be doing each of elements at different speed. For each cycle he may be taking different times for different elements. Okay, so it is better to divide the job into various elements and calculate the time taken for each of these elements. So an element is a distinct part of a specified job selected for convenience of observation, measurement and analysis. Okay, so let us see what exactly is an element. So this is a distinct part of a specified job. So, and what is work cycle? Work cycle is a sequence of elements which are required to perform a job. That is a combination of elements. So let us look at the guideline for breaking a work into various elements. Okay, so I told you it is broken down into different elements because timing a task as one element is not satisfactory. So because this will help improve the accuracy in rating, identify elements causing high fatigue, and have detailed job specification, and to prepare the standard data banks. Data bank means for each element we are defining various elements. What is the time taken for doing this element? For doing this element. So this is given to a data bank which can be used by another time study man doing a different time study for a different job, and to separate unproductive and productive elements. Okay, so this is why we are breaking the job into different elements. Okay, the elements should be of short duration as can be accurately timed. The elements should be of short duration. So it depends upon the skill of the time study man. That is how you're going to time the element, dividing into work and dividing the job into various elements and time. And elements of duration of the element, see, usually it is kept at 0.03 to 0.05 minute. Okay, any elements which are taking more than this time is not taken as element, it is further divided. And the elements should not normally be longer than 0.4 minute. Okay, so that means the range is from at least above 0.05 and should not be more than 0.4. So what are the different types of element? First one is the repetitive element, which occurs in every work cycle of a job, like putting finished work piece aside, locating a work piece in holding device, etc. Something that is an element which is frequently repeated. Then you have the occasional element, which does not occur in every work cycle, which may occur at regular or irregular intervals, like adjusting tension, receiving instructions from foreman, etc. So these are occasional elements. These are not repeated frequently. And you have the constant element, an element for which basic time remains constant, like switching on a machine. So it will not vary. It has got the same time. And then you have the variable element, an element for which the basic time varies with some characteristics of product. Okay, that means see, this takes depends upon the element, depending upon the size, depending upon the properties of the material, etc. And then you have the manual elements, that is performed by the worker. And then you have the machine element, automatically performed by powered machine, like thread cutting, right? Then you can classify the elements into governing elements, which takes longer time than any other elements which is being performed concurrently, like boiling the water in kettle while setting the teapots and cups. Okay, then you have the foreign elements, which is found not to be necessary part of the job after the analysis, like sanding the edge of board before planning, like that. Okay, so we have discussed about the how we can divide the job into different elements. Now we will see how to determine the number of cycles to be timed. Okay, so principles governing the number of cycles to get the representative average cycle time is the accuracy desired and nature of elements. So that means when you are timing a job, we are dividing into various elements, and also we are running various cycles of this job. Okay, like cycle 1, cycle 2, cycle 3, etc. Work cycle means this combination of elements for doing a job. So greater the accuracy desired, larger should be the number of cycles. The study should be continued through sufficient number of cycles so that occasional elements such as setting up machine, cleaning of machine, sharpening of tool are observed for good number of times. So if you are doing only for 2 or 3 cycles, you may not encounter this kind of a elements like setting up machine, because this happens, the cleaning of the machine and sharpening of the tool happens maybe after 10 cycles. So number of cycles should be sufficient that we can observe these elements. See, when more than one operator is doing the same job, short study, say 10 to 15 cycles should be conducted on each of the several operators, than one long study on a single operator. Okay, so it is better to do some take different operators and do some 10 to 15 cycles using that operator. So now let us discuss the concept of normal performance. So there is no universal concept of normal performance. See, it is defined as the working rate of an average qualified worker working under capable supervision but not under any incentive wage payment system. So why it is so important is that we need to define the normal performance to fix the rating. Okay, that means we need to find the observed time, then you need to multiply by the rating. Okay, so rating can be 120, 100, 90, etc., depending upon the performance. So we need to define what is the normal performance. So normal performance is the working rate of an average qualified worker without any incentive wage payment scheme. Okay, so this rate of working such that exertion of reasonable effort can be maintained day after day without undue physical or mental fatigue. Right, so he may be able to do the job with a high performance maybe for one day, but after maybe 2 day or 3 day he may get fatigued very easily, so it will affect the performance. So that is why we are defining the normal performance like this. So once we know the normal performance, we can fix the rating factor. So 100% rating represents the standard performance, and standard rating can be multiplied with any rating factor according to the assessment of the work study man. So this is the most important part. This rating factor is fixed by the work study man. He has got some methods, but usually this is a bone of contention because you can get argument with the workers when you fix the rating factor. If an average qualified worker is performing the work with 15% more efficiency, then standard rating becomes 150. Okay. So this is about the rating factor. So performance rating can be defined as the procedure in which time study engineer compares the performance of operator under observation to the normal performance and determines a factor called the rating factor. So we have seen what is a normal performance, and time study man can determine the rating factor by comparing the performance of the operator under study to the normal performance. So if he's performing better than the normal performance, the rating factor will be greater than 100. Otherwise, it will be less than 100. See, the methods for fixing the rating factor is, so there are several methods. One is base rating, then you have the Westinghouse system of rating, then you have the objective rating, and then you have the synthetic rating. Okay, then coming to the allowances. The readings of any time study are taken over a relatively short period of time, and the normal time arrived at therefore will not include the unavoidable delay and other legitimate lost time. So when we calculate one cycle, we will calculate the time taken, observed time, into rating factor. You can fix this time. The problem is that it does not include the unavoidable delay and other legitimate lost time. Okay, for example, waiting for materials. It may not be seen by a time study man, and waiting for tools or equipment, and periodic inspection of parts, and interruption due to legitimate personal needs. He may go attend the personal needs, right? So it is necessary to and important that the time study person applies some adjustment. These are called allowances to compensate for such losses, so that fair time standard is established for the given job. So allowances are generally applied to total cycle time as some percentage of it. Okay. So but sometimes these are given separately for the machine time as some percentage, and for manual effort time some other percentage. Okay. See, note that the allowances are given for interruptions which may be due to factors which are within the operator's control or which are avoidable. So for this purpose, no allowances are given. Factors which are within the operator's control. So let us see what are the different allowances given by the companies. One is the constant allowance for personal needs and basic fatigue, and then delay allowance for unavoidable delays. Okay, then you have the fatigue allowance for job dependent fatigue. Okay, Then you have the personal allowance, then on the special allowance. So this is how you calculate the basic time. So that means observed time from the various combining all the time for the various elements, then you multiply by the rating factor. Okay, so this picture, from this picture you can easily understand what is the basic time and standard time. Okay, so this is the observed time. So that means for various elements we will take the time, then we will we will take one, see, t1 plus t2 plus t3. This is the observed time. Okay, and see, you can multiply this by the rating factor. So that is fixed by the time study man. If it is 120, you need to fix the time into 120%. Okay, so that is the basic time. Then see, after that you need to give the required allowances, relaxation allowance, contingency allowance, etc. Okay, to the basic time. Thus you will get the standard time. Okay, this is how you fix the standard time. Okay, that means observed time into rating factor will give you the basic time, and plus the relaxation allowance, that is the work content, and plus other allowance will give you the standard time. So the rating factors is found by using these methods. The allowances are these methods: relaxation allowance, interference allowance, etc. And rating factor is defined as observed performance of manpower by the normal performance of manpower. Okay, now let us do one problem on the time study. So here you can see that there is a table. So the observed time in minutes for one cycle of operation consisting of 5 elements using stopwatch is given below. Okay. Calculate the standard time for the operation when elements 2 and 4 are machine element and all other elements operator is rated at 120%, and 0% allowance are provided of standard time. It is not 0, it will be 10%. Okay, so if you look at this table, you can see that these are the elements 1, 2, 3, 4 and 5, and these are the cycles 1, 2, 3 and 4. For element 1, first cycle it takes 2.4 minutes. Here it is taking second cycle, it takes 2.3, third cycle it takes 2.5, fourth cycle it takes 2.4. Okay, similarly for cycle element 2, 3, 4 and 5. Note that 2 and 4, these are machine elements. These are the jobs done by a machine, not a operator. Okay, so let us solve this. First, what we are doing is, see, we will take the element 1. So we will take the cycle time 2.4, 2.3, 2.5, 2.4. Then we will average it and you will get 2.4. Okay, you will get the average time as 2.4 minutes. For cycle 2, similarly you get the average as 5 minutes. Cycle 3 1.9, cycle 4 3.3 and cycle 5 7.2. Okay, then the rating factor is 120%. See, note that for 2 and 4, these are machine job, so there is no rating factor. Rating factor is just 1. Otherwise, here the rating factor fixed by the time study man is 120%. So you need to multiply it by 120%, you will get 2.88. Here it is 5 itself. It is 2.28, 3.3 and 8.64. Right, so these are the normal time of the elements. Okay, then you will sum these elements, right? So we will sum these elements. This is the normal time. So for a job, it takes 22.1 minutes for one cycle, for doing one cycle. And standard time is calculated as like this. So there is the normal time plus allowances. So allowances is given here. So actually this is 20 percentage. Okay, this 20 percentage allowance are provided of standard time. Okay, so 20 percentage of the standard time it is to be determined. So that means, so standard time is equal to 22.1 plus 20 by 100 into standard time, right? So standard time is equal to 22.1 by zero point 0.8. It will give you 27.625 minutes. So this is how you fix the standard time. So this is the standard time for doing that job.